Hi, welcome back to the Chemical Reactions Unit in Science 1206. I'm Miss Ledwell, and in this video, we'll start our lesson on the rates of chemical reactions. So let's get started. Let's begin by reviewing the particle theory of matter. You learned about this in grades 7 and 8 science. The particle theory of matter helps to explain the properties and behavior of materials. It has 5 main points. First, all matter is made of tiny particles. These particles are extremely tiny and cannot be seen by the human eye. Second, the particles are always moving and have energy called kinetic energy. If you add energy to the particles in the form of heat, the particles will move faster. If you remove energy from the particles, they will move slower. Particles in a gas have more energy than particles in a solid or liquid state, and they move the fastest. In our diagram on the side, the top diagram shows particles moving in a solid, the middle particles moving in a liquid, and the bottom one shows particles moving in a gas. Notice the difference in particle movement in all 3 states. The third point in the particle theory of matter is that there are spaces among the particles. The particles of a substance in a solid state are closer together than the particles of a substance in a gaseous state. Notice in our diagram the particles in a solid, liquid, and gas. Solid are closest together, liquid a little bit further apart, and the particles in the gas are the furthest apart. Number 4 is that there are attractive forces between the particles. Some attractive forces are strong and some are weak. The attractive forces of particles in a solid object are stronger than the attractive forces of particles in a gas. In our image, we see balloons filled with helium, which is a gas. The attractive forces between the particles in the balloon will be weak. The last point in the particle theory of matter is the particles of one substance differ from the particles of another substance. Each pure substance has its own kind of particle, which is different from the particles of other pure substances. In our image, the first particle is a silver bar, the second copper, and the third one lead. Each of these are pure substances. The particles in the silver bar will be different from the particles in the copper and the lead bars. Now let's look at reaction rate. The reaction rate tells us how fast a chemical reaction occurs, or, in other words, the speed at which reactants are converted to products in a chemical reaction. So remember the speed at which reactants are converted to products. Reactants are found on the left side of the arrow, and the products are on the right. Imagine watching a race. Some runners are fast and some are slow. Similarly, some chemical reactions occur quickly, while others take a long time. Every chemical reaction proceeds at a definite speed, known as the reaction rate, which can vary under different conditions. Just like adjusting the heat can change how quickly your dinner cooks, altering specific factors such as temperature or concentration can speed up or slow down a chemical reaction. Let's look at some examples of slow reactions. Examples of chemical reactions that are slow include the rusting of iron. The formation of rust on iron when it's exposed to oxygen and moisture is a slow reaction that can take months or even years, depending on the environmental conditions. The chemical weathering of rocks is another example of a slow reaction. The breakdown of rocks by chemical reactions with atmospheric gases and water is a very slow process that occurs over many, many years. Now let's look at some examples of fast reactions. Examples of fast chemical reactions include combustion, the burning of fuels such as propane in a gas grill, or the gasoline in a car engine, is a fast reaction that releases energy quickly. Neutralization is another example of a fast reaction. The reaction between an acid and a base to form water and a salt can happen in seconds. An example is how vinegar reacts with baking soda. The detonation of explosives is another example. Explosives like dynamite or fireworks react quickly to produce gases, heat, and sound. Sodium in water is also an example of a fast reaction. The reaction of sodium with water is extremely fast, producing hydrogen gas and heat. The collision theory explains that reactant particles must collide with sufficient energy and in the correct orientation for a reaction to happen. How is the collision theory related to reaction rate? The more often reactant particles collide, the more likely they are to react. So an increase in collision frequency generally increases the rate of reaction. If the particles collide with more energy, the reaction rate increases. Particles need to collide in a certain way or certain orientation in order for a reaction to occur. Now it's time to continue to the next video. First, recharge with a quick 30-second stretch. Then, please continue on to the next video.